So again, first thing is to change that example 2 to 2x squared minus 4x minus 6. Okay, graphing quadratics in standard form. Maybe we should remind ourselves what standard form looks like. So I want a quadratic in standard form. You gave me a slope-intercept line. ax squared plus bx plus c. So it's not factored, it's not vertex form, it's standard form. ax squared plus bx plus c. We'd much rather vertex form because you can just read off the vertex and then do the 1, 1, 2, 4 stuff and away you go, and that's easy. So today's a little harder because that's not vertex form. I got to do something else to figure out the vertex. But before we do that, there's still things we know and we can use. Use the a value to determine if the quadratic opens up or down. Don't worry about the minimum maximum right now. If it opens up or down, right? If a is positive, it opens up. If a is down, or a is negative, it opens down. It also tells you the stretch factor, stretch or compression. So once we do find the vertex, we can use that. We can go back to 1, 1, 2, 4 stuff once we find the vertex. Okay, here's the main thing for today. Everything else you kind of already know or you can figure out. But the main thing for today is x equals negative b over 2a. Like that's the main thing for today. Because it's the axis of symmetry, maybe more importantly, it's the x value of the vertex. X equals negative b over 2a. That's the big thing for today. After that, you can kind of figure everything else out. Once you get the x value, number 3, plug the x value of the vertex, negative b over 2a, into the function to find the y value of the vertex. Right? Just like always, if you know x and you want to find y, plug it in and see what you get. Once you have the vertex, then you're pretty much good to go because you know how to graph once you have the vertex. There's some other things on here, but like you really could almost stop here and be good because you'd have the vertex. You're all set. Now we're going to ask for more things, but you could stop there and have an accurate graph. Because once you have the once you have the vertex, 1, 1, 2, 4, or whatever the multiplier is, and you're ready to go. But there are a few other things we'll ask for. Identify the y-intercept. Y-intercept is always set x equal to 0. And if you set x equal to 0, the only thing left is c. So that's pretty easy. Number 5, set the equation equal to 0, then factor and solve to find the roots. Okay, we've done factoring before, but we haven't done factor and solve before, so we'll do that in a moment. We said this yesterday, roots equals solutions equals zeros equals x-intercepts, all of that is the same stuff. Graph all points that fit on the graph, give the domain a range, like that's old news stuff, we're used to doing that. The main thing is x equals negative b over 2a. That's how we get started today. So, example 1. F of x equals negative x squared plus 2x plus 8. Well, it's the very first one, so let's make sure we know who's a and who's b and who's c. After we do one of these, you're probably going to skip this step, but let's do one to make sure we're okay here. What's a equal? Good, negative 1. A is not negative x squared. A is the coefficient on x squared, so a is negative 1. What about b? And c? 8. And now we're ready to find the x-coordinate of the vertex. So x equals negative b over 2a. So negative 2 over 2 times negative 1. So So let's see, negative 2 divided by negative 2, that equals 1. That's my x-coordinate of the vertex. What do I do to find the y-coordinate of the vertex? Plug it in. Like, I've got the x, if I want the y, I'll plug it in. So I want to find f of 1. That will tell me the y-coordinate of the vertex. So negative 1 squared plus 2 times 1 plus 8. Oh, be careful. Am I squaring 1 or negative 1 right here? 1. And then putting the negative on. So negative 1 plus 2 plus 8, that would be 9. Right? 10 minus 1 is 9. So my vertex is 1, 9. So I can go down to my graph, put my vertex on there, 1, 9. Oh, kind of skipped over this. Is this graph opening up or down? Because A is negative, we've been flipped. And so, yeah, there's more stuff to do, but I may as well go ahead and graph some things. I know it's 1, 1, 2, 4 on either side, because there wasn't any stretching going on. There's my 1, 1, 2, 4. Let's find some other stuff here. Identify the y-intercept. Well, the y-intercept is always plug in 0 for x, which makes life pretty easy when you're in standard form. Because what do I get when I plug in 0 for x? 8. It just wipes out all the x stuff. So I get 0, 8. Now, that happens to already be on the graph. So sometimes this happens. If you do the 1, 1, 2, 4 stuff, like you may accidentally or automatically hit some of the things you're looking for. So 0, 8's already on my graph because I know the 1, 1, 2, 4 business. Let's see, number 5. Set the equation equal to 0, then factor and solve. I'm going to factor out that negative because I don't like dealing with negatives. I know some of you don't mind, and that's fine if you can handle it. I'm of the mind of why bother when I can just take it out and not have to worry about it. Let's see, so that's x minus 4 and x plus 2. So that step we've done a bunch of, right? We did it all day Friday, and then we did a little extra on Monday and Tuesday with more factoring. What we haven't done, we saw it just briefly yesterday, is to set all the factors equal to 0. So x equals 4 and x equals negative 2. Those are the x-intercepts because that's where y is 0. So let's write those as points. 4, 0, and negative 2, 0. Those are my x-intercepts. 4, 0, negative 2, 0. We didn't already have those points? Maybe. What would the next set of directions here be in 1, 1, 2, 4, 3, and 9, and so those landed at the 3 and 9. All right, graph all points that fit on the graph. All right, so we've got all the points we want to see. So we can sketch in, and now we got a very accurate graph because we got lots of points. Domain is always all real numbers. Range, remember you got to go smallest to biggest, bottom to top. So negative infinity up to 9. anything it left out? I think that's everything. Oh yeah, good catch. That should be a bracket on the 9. Definitely. I said the vertex up here. Oh, I didn't specify that. That's the axis of symmetry. What is the axis of symmetry for this one? Be careful. Don't just say 1. X equals 1. It's always the x-coordinate of the vertex because it always goes through the vertex because the vertex is in the middle of the graph. The good news is on the assignment and on the test, we prompt you for all of the things, so you're not going to forget what to give me. You might forget how to do it, but you're not going to be like, I'm going to ask you for everything. I'm not going to say, here's a parabola, give me all the stuff. Like, I'm going to prompt you for what I want. All right, let's do number 2 together. Let's see. If I want the vertex, I do, you know what, let's start with the A thing on this one. So, is this one opening up or down? A is 2, so we're going up. What about the 1, 1, 2, 4 stuff? Times what by 2? The X column or the Y column? Yeah. So A is 2, so 1, 2, 2, 8. But I still need to know where to start. I need my vertex. So negative B over 2A. So what ends up in the numerator in the top of this fraction? This is one that messes people up. So negative, what's B equal to? Well, B is negative 4. So I end up with negative 4, because B is negative 4. All over 2 times 2. So my x-coordinate is 1. If I want to find my y-coordinate, just plug it in. So 2 times 1 squared minus 4 minus 6. 2 minus 10 is negative 8. So my vertex is 1, negative 8. Negative 8. And I could work through and find all the other pieces, but I know that 1, 1, 2, 4, or in this case, 1, 2, and 2, 8 will be on the graph, so I may as well put those on there. 1, 2 on either side. 2, 8 on either side. I'm sort of accidentally finding all kinds of things when I do that. All right, I just stumbled into the y-intercept and 2 x-intercepts. Let's see, let's go in order this time. The axis of symmetry would be x equals x equals 1. And we need the y-intercept. If I plug in 0 to the equation, what do I get? Negative 6. Does that match with what I already have on my graph? So that's good. Like, this is one of those cases where the more stuff you know, it starts to like check each other. So now we're to the point where you know about 1, 1, 2, 4, you know about x-intercepts and y-intercepts, and it should all fit together. Let's see, for x-intercepts, we set y equal to 0. This time I can factor out a 2. that's x minus 3 and x plus 1. Set the factors equal to 0. The 2 out front, that doesn't do anything. 2 can't be 0, so I don't have to worry about that. So x minus 3 equals 0, x plus 1 equals 0. So 3, 0, and negative 1, 0, which we also already had on the graph. What happened? How did I get?
The equation is 2x squared plus 4x minus 3, not negative 6.
Oh, I changed it. Remember we changed it at the very beginning? That's why. Because the other one wouldn't work. So we find our x-intercepts, but we realized we already had them on our graph. So we're good to sketch in our graph now. Main, all real numbers, range, bottom up. I'll remember to put a bracket on that one. So negative 8 to infinity. Okay, today's assignment is worksheet 4.1. There's 8 of those graphs, but let's do a couple of them together. Make sure we're okay. Let's just start with 1 and 2 and see how we feel after that. You know what? Let's read the directions, and I'm going to kind of annotate the directions to give us hints along the way. So identify the vertex. What do we do to find the x-coordinate of the vertex? How do I find the x-coordinate of the vertex? Negative b over 2a. And that's the same thing as the axis of symmetry, so we're good there. How do I find the y-intercept? Don't tell me what it is, tell me how I find it. Set x equal to 0. Which means, how do I find the x-intercepts? Set y equal to 0, usually factor. Domain, range, graph, we've done a bunch of those, so we're good there. Okay, so number 1, x equals negative b over 2a, and I got to fit all of it in somewhere. What's b equal to in this one? 0. Good. It's not the second number, it's the number that goes on the x. And there's not a number on the x, so the b is 0. Which means it doesn't really matter what a is. So the x-coordinate of my vertex is 0. How do I find the y-coordinate of the vertex? Plug it in. So 0, negative 1. Which, we could have graphed this one from transformations, because what's that minus 1 doing in terms of transformations? Down 1, and that's what we just figured out. Okay, axis of symmetry. That's our vertex, so I know my axis is going right through that vertex at x equals 0. My y-intercept, I kind of already, I just found it, right? That's on the y-axis, so if you found it already, you don't have to kind of go through the process. I can see that my y-intercept is 0, negative 1. For my x-intercepts, I need to set the equation equal to 0. Let's see, that'd be x plus 1 and x minus 1. When I factor it, so x equals negative 1 and x equals 1. I want to list those as points though, so 1, 0, and negative 1, 0. Hey, I kind of knew those points already, right? That's the 1, 1 set of points. So I might have already had those. Let's see. Vertex, axis symmetry, y-intercept, x-intercept, domain and range and graph. Let's add 2 more points because we know the 1, 1, 2, 4 thing. So may as well add the 2, 4 set of points. Domain, all real numbers. Range, negative 1 to infinity. Again, the only new thing today is the negative b over 2a. Everything else you're supposed to already know, I guess. Phrase it that way. Questions on that one? Okay, let's do number 2. Why would I pick number 2 to do? Because there's a fraction there. Let's see. Maybe I should have done this first on the other one. A is negative 1/2. So what does that mean about my graph?
It's going to be a compression.
It's going to be a compression. True. What else? It's going to flip. But you're right. That means I'll multiply the y values by 1/2. So if you're thinking that, you might want to go ahead and set that up. So once I find my vertex, I can go find the other points, or some other points. Okay, but now sort of back to the top here. We made our observation. Let's do x equals negative b over 2a. So negative 6 over 2 times negative 1/2. That actually works out okay. Right? Because what's 2 times 1/2? 1, and then negative 6 over negative 1 is just 6. So not awful. Yet, anyway, maybe. What do I do to find the y-coordinate of the vertex? Plug in 6 and see what we get. Negative 1/2, 6 squared. Plus 6 times 6 minus 19. That looks terrible. Let's see what happens. Oh, order of operations. Do I take half of 6 and then square it? Or do I square the 6 and then half it?
Square 6 first.
Square the 6 first. So that's 36. Half of 36 is 18, but there's a negative on there. So negative 18 plus 36 minus 19. No. They kind of did us a favor here. That worked out to not be too bad. Negative 18 plus 36 is 18. Minus 19 is negative 1. So a vertex at 6, negative 1. We already talked about what A is, so let's go ahead and use those points. We know it's flipped. We know it's compressed. So I'm going to go over 1, down 1/2. And over 2, down 2. And I think that's all that's really going to fit on my graph here. Now let's go back and make sure we answered all the questions that they asked us. Vertex, got that. Axis of symmetry. I mean, I didn't list it, but I kind of have it, right? What's the... Yeah, x equals 6. y-intercept. Kind of doesn't look like I have one, maybe, but if I plug in 0, what do I get for an answer? Samantha, if I plug in 0, what's y equal to?
-19.
Do you know where that came from, or did I hear Ava whisper it? Okay, good. 0, -19. So yeah, that would be way down here. That's not going to make it onto the graph. How about x-intercepts? How do you know there aren't any? Okay, yeah. It's like, look at the picture. The vertex is below the x-axis and it's going down, so there aren't any. Which is good, because I was worried about having to try to factor that thing and set it equal to 0, but there aren't any x-intercepts, so I don't have to worry about it.
So on the test, if we find out all the rest, and it's like that, do we still have to show it for x-intercepts, or can we just say that?
You could just say none. And what you also could do, well, we kind of got away with one on number 1. Speaking of, like, as you do the graph, how much work do I need to show? Like, if you did the 1, 1, 2, 4 thing first on number 1, then you could get the x-intercepts without having to factor, because they just showed up when you did the 1, 1, 2, 4 thing. All right, domain is all real numbers. Range is -infinity up to 1. And now I think I've answered all the questions. X equals -b over 2a. X equals -b over 2a. X equals -b over 2a. That's the main thing for today. Why don't you try number... I guess we'll just go in order. Try number 3. Try number 3. Okay, what else is left? X-intercepts, y-intercepts, axisymmetry, just domain and range. Domain, all real numbers, range, -infinity up to 1. Bracket to include the 1. You tell me, what do you want to do number 4 together? You want to try it on your own? Peek ahead and try one? Number 4, you do get a fraction for both coordinates of the vertex. Yep. So try number 4, but the caution is both coordinates of the vertex are a fraction.
Do we have to write them both in fractions?
You can do decimals either way, because they're both 0.5 things, or half things. So yeah, annoying. Which means if you do the 1, 2, 2, 8 stuff, you're also in the middle of squares. I don't know if you want to do it or not. Maybe we have nice x-intercepts. Maybe we have a nice y-intercept. So let's try that first. The y-intercept is nice. Y-intercept is almost always nice. Max, if I plug in 0 for x, what do I get? -4. And because of the symmetry, I didn't write the axis of symmetry, there's also a point on the other side of the axis of symmetry if you want to include that one. Alright, for x-intercepts, I need to set y equal to 0. I'm going to go ahead and factor out the 2. Squared minus x minus 2. And that will factor, so that's good news. Now here comes kind of a moment of truth. Let's see if my factored zeros, if my zeros, my x-intercepts, my solutions, when I put them on the graph, here's where we'll see if they make sense, right? Because if I put them on the graph and they're like over here, I grab the pencil because that's not where they are, then I would know, wait a minute, I did something wrong. So here's my first chance to kind of check and see if I'm doing this right. X equals 2, x equals -1. Does that look symmetric? Yeah, those look like they're where they're supposed to be. So that's good news. I feel good about my x-intercepts. And I think that's all the pieces, and I've got a lot of points, so I'm ready to sketch in my parabola. That's the only one that has fractions in the vertex. Just double checking that. So in some ways that's the worst one with the fraction stuff. But it was only in the vertex and it didn't really show up anywhere else, so it really wasn't that big of a deal to have those fractions. This is all we're doing today. This is also due on Friday. No, we still got 40 minutes left. You got time.
Wait, only this side? Only this page?
No, both front and back.
Oh.
But the back has only 2 graphs and then more factoring practice. So you've got plenty of time left to work on this page. Answers are on the board. It is due Friday. I usually don't like making things due the next day, except when I give you 40 minutes to work, then I don't feel so bad.
What did you get for the range of 4?
The range of 4. Yeah, I never really answered that question, did I? Oh, that's kind of yuck because of the...
Yeah.
So what did you get for the range of 4?
-4.5, -7, or
Yep. Yep. So yeah, kind of weird with the half in there, but you got it right.